All right, it's about time. Let's get started. First, quick selfie to show all the people super excited about automated testing. Hey, great. All right, so my name is Billy Korando. I'm really happy to see so many developers here interested in automated testing and learning about JUnit 5. How many people know or use JUnit 5 already? A couple? Okay, not to me. So I can kind of make up this whole presentation. No one can call me out on it. That's really important. No. So, Vincent, my name is Billy Korando. You can follow me on Twitter at Billy Korando. So if you have any questions after this presentation and you don't get a chance to ask them, feel free to send me a message. I will try to answer that question. And I'm a developer advocate with IBM. So let's get started. A lot to talk about in these 45 minutes. Let's jump in. First, though, I just want to talk about IBM. We run an initiative called Call for Code, which we run with the Linux Foundation and the UN, and it's about how developers can help out addressing like real important things like climate change, environmental disasters, and so on through the job that we love and do, which is programming. So definitely check that out if you get a chance. Also, IBM is doing a lot of really great things. OpenJ9, which is our own JVM, which is really great when it comes to CPU and memory consumption. OpenWhisk, which is our serverless implementation, IBM Cloud, and a couple other great things. So check that out. We're really trying to get back into the Java world. All right, so JUnit 5. I'm guessing everybody here has some experience with JUnit 4, and you're like, okay, wow, JUnit 4 is working good for me. Why do we need to change? Well, a lot has changed since JUnit 4 came out, which I believe was 2006. And of course, the goal with any major revision is to try to address some shortcomings. So one of the biggest things is to modernize. A lot has happened in the 11 years between JUnit 4 and JUnit 5. And the biggest one is Java 8. And so JUnit 5 has a Java 8 baseline, and that came with lambdas, streams, default interface methods. And we'll see how that plays into JUnit 5 during this presentation. Another goal with JUnit 5 was to modularize. Instead of a single jar you'll bring in, like with JUnit 4, there's actually several different jars you'll be bringing in, kind of depending on what you want to do with it. And we'll kind of see what that looks like. Extensibility. JUnit 5 is really, really, really great when it comes to being extendable to kind of address the domain concerns for your company. And we'll see that also. And finally, backwards compatibility. You have a lot of tests probably already written in JUnit 4. You don't want to have to rewrite them all in JUnit 5 if you want to upgrade. So what do I mean by modularity? So this isn't going to apply too much, but it's kind of good to know when you kind of see stuff being brought in, or maybe when people are talking about it. So there's three major modules to JUnit 5. Vintage, that's what covers the backwards compatibility, which I just mentioned. The platform, that's for test launcher and tooling support. And finally, what we're going to really be talking about during this presentation is Jupyter. If you're wondering why it's called Jupyter, well, Jupyter is the fifth planet from the sun, and it also just so happens to be begins with a JU also. But yeah, that's generally what we're going to be talking about with JUnit 5. That's the new programming model. All right, migrating into JUnit 5. As mentioned, you have thousands of existing tests. Do I need to rewrite them just to go to JUnit 5? And the answer is an emphatic no. JUnit 5 offers great backwards compatibility. So let's go and take a quick look at what that means. So first, let me just go on and quickly comment out all my JUnit 5 stuff. All right, I'm going to tell Eclipse now to run these tests as JUnit 4 test. Of course. Okay, as these run, so obviously these tests aren't going to be necessarily as complex as a full-on enterprise test suite for whatever application you're running, but these aren't just hello world. either. So first, I just have like a relatively common just test for like a service class you might have, but I'm using a few rules here. Also, has anybody here heard of test containers? One person. So test containers is a really great library. It's for spinning up and tearing down Docker containers within your JUnit test, which is great for doing like integration testing. But anyways, I'm also running one of those tests, which also depends on rules, and a couple other things that depend upon runners, specifically the Spring Data runner for a JPA test. So some complexity, not a whole lot, but at least it's not just very, very basic test. Anyways, running these back in JUnit 4, they all succeed. Let me go back here real quick. Uncomment all that stuff. If I run this again, so it's going to take a few moments to run through all these tests again. Everything should pass, but that's just so it's like JUnit 4 or JUnit 5 has had really great backwards compatibility. It's up to JUnit 5.3, and in that entire time, very, very few changes have been made to the Java 4 support because there hasn't been really many bugs or issues. In all the testing that I have done, I haven't really run into JUnit 4 or any issues with backwards compatibility. So that's probably one of the most important things. If you have a huge amount of existing tests, thousands, you're not going to want to have to rewrite them all if you want to upgrade to JUnit 5. And then also that you may kind of have a hard time determining your baseline if you have to rewrite all that stuff. You don't know what's failing, if it's because of JUnit 4 or JUnit 5 changes. You have no worries about that. I'll let this run in the background. We'll get back to it in a moment. Just want to get everything covered. All right. So what are the migration requirements? If you want to actually start using JUnit 5, what do you need to do? As mentioned, it's a Java 8 baseline, and also the JUnit team has been really, really great about keeping up to date with the latest Java release. It's already working, just runs like heaven on Java 11 is, I believe, the hashtag, and I believe it's already compiling and working against Java 12. So if you're also keeping really current with the new Java release cycle, JUnit 5 is right there with you. As mentioned, JUnit 5 has been out for just over a year now, so really, if you're using IntelliJ or Eclipse, any recent within the past year or so release will work great. NetBeans 9.0 is coming soon, and JUnit 5 support should come with it. It's also in the snapshot builds. Gradle 4.6 or later, and then Surfire 2.19 or 1 or later will work. Though we'll talk a little bit later how we actually want to be on the most recent Surfire on failsafe of 2.22, which is a little bit easier to configure when it comes to JUnit 5. All right, so it's easy enough to start using JUnit 5, but why? Why do you want to make that upgrade? Well, let's start taking a look at, maybe start selling you on why you should be using JUnit 5. All right, our tests are finally running. And while they're still running, I'll go on and start working on updating a test to use JUnit 5. All right, so I just copied over a class that's written in JUnit 4. So yes, all of our tests passed. The demo gods are still happy with me for right now. Let's see. That is not correct. Well, I guess Eclipse is acting finicky for me because I just deleted this class just before I came in here, and it's bringing in the other one. But the things to remember when upgrading to using JUnit 5 is it has come with, in JUnit 4, there's a package structure that came with it. So you would use org JUnit assert equals or for your assertions. Instead, with JUnit 5, that will be under org JUnit API assertions for all the different assertions that they offer. And then also instead of org JUnit test, you would use also org JUnit Jupyter API test. So you want to be using the test and assertions under the Jupyter package, Jupyter API package when using JUnit 5, because that will then be using the new programming model. Fortunately, again, oh, yes. Sorry. Thank you. And also, a lot of what I talk about here, I've been blogging heavily on JUnit 5 over the past year or so. And I'll have links to it, but almost everything I cover has also been covered in blog form. In case there's something I missed or wasn't that clear on, you can kind of look at it in a longer blog form, also on your own time. Anyways, so this has been updated to using JUnit 5. Let's go in and execute it real quick. So we have 4 tests, one of them failed. So one of the things that has changed is JUnit 5, in JUnit 4 there was rules, and all those rules and extends with, or rules and run with and all that has been rolled up into the new extension model in JUnit 5. However, you might still be using rules at your organization. So if you want to use rules still, you will need to use this JUnit 5, or enable rule migration support, and also you will need to bring in the dependency JUnit Jupyter migration support to use rules in JUnit 4 or JUnit 5. But if we run this test again, everything passes. All right, but again, a little bit, why do we want to make this upgrade? So one of the cool features, or one of the many cool new features in JUnit 5, and that this is also because of the Java 8 baseline, is the new assert all. So who has ever been in the situation of, like in this test, you have multiple assertions, one fails, you fix it, and then you find out the next one fails, and you get into this really annoying cycle of having to run a test 3, 4, 5 times or even more, just because you're having to progressively go through every assertion failure. So now there is a new assert all, and so if I just go ahead and set all these to a wrong value, and run this test again, now, instead of just getting the first value that failed, the ID, we get all these back here. Back here, all 4 of the assertions show up as failed, so that's very helpful. But really, actually, the one and only reason you do want to upgrade to JUnit 5, this is by far the coolest feature. You can do a display name. And if we run this test again, we will get a really cool name as a name, but that's not all. See, a few people already kind of know what's coming. Yes. There is now emoji support for test names in JUnit 5. So run this again, and now we get emojis. Of course, I do this for humor. There is, the JUnit team didn't actually set out to support emojis. They were just supporting Unicode, and of course, that came with emoji support as well. However, how they could actually be useful is if you're doing international translation, you can maybe perhaps put the country flag next to the translation that's going on, or maybe you have maybe certain important tests you want to put a alarm siren next to. You can also do that to say if this test is failing, that could mean something's really, really wrong, though really all your tests should always be passing anyway. So, but that's just one cool thing. All right, so it's starting to get a little bit of a taste of why to upgrade to JUnit 5. I've also, as I mentioned, these are kind of the language changes, the new package structure. Also, so in JUnit 4, we had the ignore annotation if you want to skip a test. That has been changed to disabled. We'll get a little bit into that as well. As mentioned, run with, rule, class rule has all been rolled up into extend with. And before class and before, and after class and after have a much clearer names of before all and before each. Same functionality for those, but just a bit more clear, which I always appreciate. All right, so let's get into the extend with the new extension framework. The extension API, as mentioned, rolled into the new rule, class rule, run with, rolled into that. So there's several ways you can register an extension. There's at the top, kind of like how we have run with, you can do extend with at the top, and that declares it declaratively for our entire class. There is also the register extension, which you can kind of declare programmatically, and that way you can actually have access to class members. And also using the Java service loader, extensions that can be declared globally. So again, we can just kind of look a little bit at that. Yes, that's right. So yeah, up here is, and we can also here see as well, so you can do extend with. So you can do this if you want extend with Spring class extension. But one nice thing, as I mentioned earlier, is extensibility was one of the real key changes made in JUnit 5. And so what you can do instead, doing extend with and trying to remember the class name can be a little bit difficult. Only because I've done this so many times, I can kind of remember its Spring extension. Instead, what you can do is like this Spring JUnit config. This is supplied by the JUnit 5 team, or the Spring team. It's just an annotation interface, and it just has this already built into it. So that way you can just kind of have stuff in your own domain or combine stuff together so you don't have to remember so many different things. And we'll see a little bit more. It's super easy to do extensions or extending upon JUnit 5 features for your own needs. So this is, again, a way to declare extend with at the class level. Here, I mentioned again test containers. You can do, like, for example, declaring programmatically an extension. And this is a very simple extension right here that it's just kind of for setting up and tearing down my test container. But yeah, this is an example of, man, the back on Eclipse is not working that well right now. An example of registering one programmatically. I have a blog that kind of goes a little bit more into depth on what this all means. But yeah, there's multiple ways. But again, like probably the big thing is like you can have access to members, class members, when you declare it programmatically. And I think I also have an example within my test. So is everybody here, or at least kind of heard of the Java service loader functionality? So what you can do is within meta-inf under your class path, you have services, and then you name the exact location to the text execution listener, and then you kind of reference the extension you want to have automatically loaded. And where this can be helpful is if you want to have an extension that's going to be part of every test in your entire test suite, you can just declare it here instead of having necessarily put that extend with annotation on every single class. So that can be good. In this case, part of JUnit 5.3, they were able to start capturing console output for like doing reports, and so like that's kind of what I'm doing here is have like a really simple console output listener to kind of check for that for generating reports. All right. Next, dependency injection. That's another area, a huge amount of support. You can pass values from the container into constructors and methods. There's also the new value test info is always available and can be passed into a test case. And also with in 2.21 of Mockito, they also support injecting dependency or injecting mocks directly into classes. So let's take a quick look at what that looks like. So for example of, to do the injection of mocks directly into a method with Mockito, you would need to use extend with Mockito up here. And then you would also, in the method, declare @mock and then the class that you're mocking. And then that way we don't have to, within the class itself, set up a mock. And then you can run it. And this would run just as it did before. And this can be helpful. Obviously, you can just do this at the field level and for a class and just use that mock through all the different test classes. But this can be helpful to kind of describe within the method signature what kind of dependencies this test is working on. It's also a little bit cleaner than having to like maybe do this in every test case as well. Or you can also, maybe you want to use one mock for all the other test cases in your class, but within one specific test case you want to use a different mock, you can also do that as well. There's also, as mentioned, the test info that's always available. And we quickly execute this then. And so this test info obviously gives us information about a test. And this could be pretty helpful for debugging purposes. Like, why is this test not running? Why is it failing for some reason? You can kind of see, oh, actually, maybe you thought something that was going on isn't actually happening. And so that's also cool. For JUnit 5, or for Spring people like myself, you can also even do actually I do have a better example, I believe. Yes. Yes, so also if you're using Spring, you can do @autowired to also inject something in. And you do have to do @autowired even like if you're using Spring 4.3 or later, like you would still have to do the @autowired even if you only have a single constructor, just because it's JUnit 5 that's actually kicking it off. It does not discover it in a Spring container. But yeah, you can do @autowired both at the constructor level and at the individual class or method level as well. But very helpful. That way you can kind of declare really individual test cases, what you're depending on in that test case, not just jamming out all in as fields. So parameterized, repeated, and dynamic test. So parameterized tests, instead of having to declare that at the class level with run with parameterized class, you can declare it at the individual test class level or individual method level. And you can also have a lot of different sources between like value source, method source, enum source, and so on. And also new in 5.2, if you're already using JUnit 5, but maybe something before 5.2, there's also the new argument aggregator. So let's take a quick look at all that. So in this case, parameterized test is already set up, and I'm telling it to use the method source of data, which is here. And so another thing is that if you want, you can also just name this the same as the class that's running. And if I do that, by default, it will also just pick that up. But you do need to return, I believe it's a stream. Yeah, I think it's only still streams that are offered. And then whatever data type, and that just needs to match the data type of whatever argument that's going into that method. But this is really nice. At a previous employer I was with, I had a situation where I was having to write a parameterized test, but because I was in JUnit 4, I had to use the run with, and you can include other tests within that same test class, and it was very frustrating. So I had about 15 test cases I could do in a parameterized test, but there's about 2 I had to do outside of parameterized tests because the scenario was so different, but I had to locate those tests in a whole separate test case or test class, and that was a bit frustrating. But now, if I just run this entire test class, as you can see, we have both the parameterized test that we run and then just a blank test as well. So that can be very helpful if you ever run into that situation. You can still locate everything within the same test class. Some other cool things then. As mentioned, so there's values source you can have, and so that's just a list of strings. But then there's by default, URI, file, locale, and so on are all automatically translated. Translated by JUnit 5, so that way you don't have to do like a URI or file up here. It automatically recognizes that, that this is a valid file, and because I declare it as a file in the argument for the method, it can just check to make sure that, hey, these files, like for example, do exist. You can also do this customized as well. Unfortunately, I don't have an example of that, but there is an example in the JUnit 5 docs, which are fantastic, and I have a link to that at the end of this presentation. And then finally, also just an example of using the CSV files. Let's see. Yes, sorry. And just JUnit 5 is this big enough, or could it be a little bit bigger for the text? Okay, great. So initially, you would have had to match all of the column names with the method signature, and that would be very frustrating because if you made any additions to the column signature, you had to go through and redo a bunch of tests to update that. But now they have the argument accessor. And so here, I'm just taking in these 3 or 4 arguments depending upon the test, and I can just kind of set them to the here. But that's a lot of code. That's a lot of code, especially maybe if you're doing that in a lot of areas to put in every test case. So now they have what's called aggregate with, and I can take all that I'm kind of doing right here and then move it into this data bean validation bean aggregator. So just kind of extract that out, and so my test case is much cleaner. And again, this is the extensibility I talked about. So instead of having to do aggregate with and the data bean validation aggregator, I can just use this annotation that I wrote myself that's within this project itself, and just do aggregate with bean data validator aggregator to make things a little bit simpler for other developers. And of course, also, you don't just have to do like CSV source like I'm doing up here. You can refer to an external file. All right. Repeated tests. If you just want to execute a test case many times, you can use repeated tests for that. I have an example of that. It's not that interesting example, but you can also check that out if you want. What I do find really interesting, though, and it took me a while to find like a really good test case or example of it, is dynamic tests. And so what I have here is, like, let's say, for example, you're developing a RESTful application. And yes. So let's say you're setting up a RESTful API. And with that API, you need to be able to accept both JSON and XML. Writing out tests for every single endpoint, maybe post endpoint, and make sure it's accepting both XML and JSON would be laborious. And it could also be very easy a case where a new developer adds a new post endpoint, forgets to like set it up correctly, and also forgets to write the test, and then all of a sudden you're kind of running into like a problem in production because no one else maybe tested it, and you're getting some failures. So in this case, I'm using a dynamic test. So with a dynamic test, you're going to annotate a method with test factory. And then it needs to be a collection of either dynamic nodes or dynamic tests, or dynamic container or dynamic node, dynamic test. And what this is doing is I'm using Spring to kind of scan the class path. And, with the test factory, you're kind of going to be designing it to like, what is a test supposed to look like that I want to run? And anyways, I'm having Spring scan my class path, look for any post endpoints, and then up here, I'm kind of declaring what sort of media types I want to have tested. I know this is a lot of information. I do have a long blog about this that kind of goes into much more depth as well. But anyways, if I run this test, I believe I will get either two, yes, I will get two test runs. And then if I go up in here to my controller, and if I uncomment this post mapping and I run this test again, now I get 4 test types, or 4 test runs, because it detected the second post mapping, and it's going to test it automatically. But this is just a great, maybe one, like a practical example a little bit if you use a dynamic test. Another great example might be for like security testing. Maybe you want to say, okay, for everything that has like an admin within its endpoint, maybe it has to have a certain different security level from everything else. But there's definitely some really practical reasons to use dynamic tests. And like I said, I have a more extensive blog article on how to use dynamic tests. Because I know this is probably like, wait, what is he talking about? This is a lot of information all at once. Test interfaces is another really great thing. So test interfaces, so JUnit 4, you have an abstract test where you could, or an abstract class where you could declare some test within it. But of course, the problem is with JUnit or with Java is you can only have single inheritance. Of course, you can also then implement multiple test interfaces or multiple interfaces within a Java class. And where this can be useful and interesting is, an example I have is REST APIs. We've all maybe probably worked with them to some extent. And how many times have you had a REST API where you call it and it returns a 200, but within that 200 is an error message? Like, I think we've all run into that many times. A lot of people don't follow the RESTful spec. Maybe you should and shouldn't. But in this test interface, what I have set up is using the default methods default interface methods that were introduced in Java 8, you can write a test. And so what I have is a series of test interfaces for delete, get, put, post, and also doing search and gets, following like a predetermined path of how to properly write a RESTful API. I just did RESTful as an example because it's something that a lot of developers have had some experience with, and it's also a publicly accessible pattern. But this could also be done with like maybe DAOs. Some of your database control or database objects are going to be either maybe you're only going to be doing reads in some areas, or maybe for some areas you're going to be doing reads and writes or other things like that. Where what is interesting about having test interfaces is you can help a developer with writing tests, but you can also help enforce following a certain pattern. But sometimes those patterns, you're not going to always do all that. Not every RESTful API is going to have a post and put endpoint. And by pulling this apart into like, okay, if you're going to be doing gets with this controller, then you'll implement the get interface. If you're going to be doing the get, put, and post, you can also then put that all together. And so what I have here then is my customer's controller. And I just only have to implement a few methods, and usually it's just one line. And then using those test interfaces, it's going to both help with running those tests and then ensure that it's following a specific pattern. For example, with like get or with REST is like the base endpoint is always going to be customers. And if I'm going to be getting like a specific customer, it's going to be customers and then that ID. And these tests are enforcing that I'm following that pattern. And again, I have a blog article that gets more in depth on this to kind of help maybe explain it a little bit better than can be delivered live in a presentation. But yeah, so just went through, just tested, and it's just both making sure, helping with writing the test and then also making sure I'm following a pattern. But this can, again, I said, it can go farther than just necessarily something like REST. It can be like also for doing DAOs or some other pattern that's going to maybe be common to your company or your domain. Disabling and filtering. As I mentioned, ignore is now disabled. And so disabled isn't just like ignore where it's just going to skip a test. You can also set conditions for that. For example, operating system, JDK version, or there's also custom logic. So this can be particularly great with operating system is like maybe most of your developers are using a Unix system or Unix-like system, but maybe a couple are using Windows. You can have it to where a test is disabled on Windows if it's maybe accessing a file on the computer. And that way, if a test, those tests fail for the developer, you don't have to explain like, hey, it's fine for these 3 tests to fail because you're running on Windows. You can just disable them altogether so they're skipped, so you don't have like that weird and awkward conversation, or you're not always having just to skip those altogether. Also filtering, you can put tags on a test, and then you can configure within Surefire to say, hey, skip some of these tests. Now, one thing to keep in mind, so if you disable a test, that will show up as skipped in your test report. If you filter a test out, it will just not show that. So like, let's say you have 10 tests and you're filtering 5 of them. In your test report, it will just say 5 tests have been run. It makes no mention of the tests that have been filtered. Let's take a quick look at that. We are quickly running out of time. There we go. So I am disabling this test for a Mac. If I run this again, it will simply show up as skipped, as you can kind of see up here. If I was to just change this to then Windows, as I mentioned, I run this again. And now that test actually executed. Like I said, there's Java levels, operating systems, and so those are some of the things that are already default implemented with JUnit 5. But you can, there's also, and I can't quite remember, but I'm not great with JavaScript. You can even put a valid JavaScript within this string up here, and then also disable tests that way. And finally, you can create your own you can also implement the execution condition. And in this case, when I first started presenting on JUnit 5, they didn't yet have the operating system as a default implementation. But if you implement the execution condition, you have a huge amount of access on how you want to disable an application or how you want to disable a test. And then here, I created my own custom annotation, extend with disable on Mac condition, disabled on Mac. And if I was also just Mac, if I run this test again, it will also once again be skipped based upon that execution condition where I'm looking for a Mac operating system. So a lot of different ways to provide custom implement logic to maybe when some tests should be skipped. New in JUnit 5.3 is parallel test execution support. Also, sorry, let's go into the I do have a blog article where I go into the disabling filtering, but for time, I don't want to have to go through and kind of type that all out again. But there's very powerful support where you can configure within your Surefire plugin or your failsafe plugin on tests you may want to skip in certain scenarios. So parallel test execution. All right, that's not there. So to set it up, you'll within on Maven Surefire, you'll set up JUnit Jupyter execution parallel enabled, and I'm just doing this by parameter, but of course that would then be true if you weren't doing that. And there's different ways of how many tests you can run in parallel. In this case, I am doing parallel dynamic factoring. And so what that means is JUnit will look at how many cores are on the system that you're running. So like in this case, I believe I have 4 cores on this laptop. And with a dynamic factor of 1, that means 4 tests will execute in parallel. If I was to do 2, that would be 8 tests, potentially 8 tests running in parallel. There should also be, I believe it's static, where you can always sit here and say, we only ever want 2 tests to run in parallel, no matter how many cores might be on the system that's executing the test suite. But you also have more control than just that when it comes to how tests to be executed in parallel. All right. So what you also have is this annotation resource lock. And so then what you would have is a value of logging. And so this is arbitrary, but this is just to associate tests together. So I'm just saying in this value, all these tests are executing the same area that is relevant to the parallelization. And then there's also 2 modes, read, write, and then read. And so if there's tests that are marked read, write, then they will be executed in serial because you're maybe making some sort of state change. And obviously, you don't want to have tests running in parallel when that is happening. Read, these 2 tests can be also executed in parallel. However, they won't be tested at the same time when another read-write test is being executed. However, there's no order guarantee, so these tests might be executed either before or after the read-write test. So, like I said, read tests, they can be executed together, but they won't be executed at the same time as read-write, but they can actually, yeah, there's no order guarantee there. So that's not all. There's a lot I still have yet to cover. There's nested tests. There's assumptions. You can also execute tests out of a console launcher that JUnit 5 has. Also, anybody here using AssertJ or Hamcrest? A few people. So I love AssertJ, and adding or using AssertJ assertions instead of the default JUnit 5 assertions, there's no problem. It works perfectly. And same with Hamcrest. And again, you can just check out the JUnit 5 user docs. And as I mentioned, again, the user docs. But these 2 links, I've written a bunch of articles on JUnit 5. You can find a lot of them at this first link. And then also a few more here out on my Medium blog as well. But check those out. Pretty much everything I talked about during this presentation I covered in these blogs as well. But also, by all means, if you have any questions, I will be more than happy to answer them. You can, again, follow me on Twitter, and you send me a message. I'll get back to you for sure. But yeah, just a few more things. If you're interested in IBM Cloud, there's a link for signing up. Here's the link to these slides. And then, of course, here is a link to a lot of the code I did. And then I also have, again, links to the blogs I just talked about, as well as to a couple other code projects where I explore JUnit 5 topics. So I have about 2 minutes for questions and answers, but I hope you enjoyed this presentation. Thank you very much for coming.